about electron configuration and the periodic table. In this section, we're gonna learn a little bit more about the periodic table and discover the fascinating structure, organization, and application of the periodic table in chemistry and in our daily lives. First of all, the first thing that we need to understand about the periodic table is that it is organized in groups and periods. Here we can see the groups, the vertical columns right here, and the periods are the horizontal columns right here. For this course in particular, we're gonna be talking about representative groups, which are the ones here in red and also in yellow. We're gonna be talking about the transition elements later on, and these are also inner transition metals, but not really for this course now. But these are the ones that we're gonna be talking about in more detail. So group number 1, group number 2, and then group number 3, 4, 5, 6, 7, and 8, or 13, 14, 15, 16, 17, and 18. So the periods provide information about the energy levels. So here we can see that we have 1, 2, 3, 4, 5, 6, 7 different periods, which means that these atoms in this period have 1 energy level, 2 energy levels, 3 energy levels, and so on. So the elements in this 7th row are elements with 7 energy levels. As you can see here, this star is because this element should be here and this element should be here, but in order to make the periodic table shorter, they put them apart. Also, here with these groups, the ones that we call representative elements, they have the numbers based on the valence electrons or the electrons in the outermost energy level. These electrons are very important because they provide chemical properties to the substances. So here in group number 1, we have that all of the elements in group number 1 have 1 valence electrons. In energy in group number 2, 2 valence electrons. We forget about these elements in the middle. And then we come here to group number 3 or 13, 3 valence electrons, 4 or 14, 4, 5, 6, 7, and 8 valence electrons. With the exception of helium, because it has only 1 energy level and the maximum electrons that it can have is 2. But all of the others in this column, they have 8 valence electrons. So as we can see, these representative elements, or the groups in 1, 2, 3, 4, 5, 6, 7, 8, they do have specific names. So the ones that you just need to remember is that group number 1, they are called the alkali metals, and they have all 1 valence electrons, and they form ions with charge +1. In group number 2, we have the alkaline earth metals, and they form ions with charge +2. Here, this is they don't have a specific name, but we call it the boron group because this group starts with boron. This is the carbon group, and then the nitrogen group. This is chalcogens, but we don't really call it we don't really use this name that much. We say oxygen group. But this one, number 17, that has a very specific name that is called halogens. This group 17, and they all have 7 valence electrons, and these ones are called the noble gases, and the noble gases, they have full outer shell or 8 energy valence electrons, except for helium. These are names that you need to become very familiar with, because often we're gonna just say the name of the group and not the number. So alkali metals, alkaline earth metals, halogens, and noble gases. So the position of the element in the periodic table is somehow related to the chemical properties. So we're gonna just see that the reactivity varies in the periodic table. We're gonna do a laboratory about the changes in reactivity. Also the metallicity, or the metal character, that we can see that a periodic table is separated as well into metals and non-metals, and in between metalloids, something that is not exactly a metal and is not exactly a non-metal, something in between. And hydrogen, sometimes you will see that hydrogen is not placed in either side of the periodic table, but right in the middle, because hydrogen has 1 valence electron, and that's why it is placed in group number 1, but it's also a non-metal, so it should be like on the other side. But it's that's why you can see that hydrogen in some periodic tables can be found in the middle of the periodic table. So somehow to recap at this moment, you just need to understand that the valence electrons or the electrons in the outermost shell are very important for the chemical reactivity of the substances, and for the representative elements, it determines the group number. So one valence electron is group number one, two valence electrons, group number two, and so on. And also that in the same group, because of these valence electrons, the elements in the same group share similar chemical properties. They're not exactly the same ones, but we can say that, for example, group number one, they are very reactive. And they don't have the same reactivity because it also varies down the group, but they share some similar properties as well. Um, so here, remember that based on the structure of the atom, we have the energy levels, and this is the planetary model according to Bohr. And if you think of the atom as a building or skyscraper, it's like having 7 different floors, and in each floor you have different types of apartments. That's more or less the same thing for the energy levels. So in this case, what you just need to remember is that the energy levels are related to the periods. So all of the elements in period number one, they have one energy level. Period number two, two energy levels. Period number three, three energy levels, and so on.